Welcome to the Analytics Engineering Podcast, featuring conversations with practitioners inventing the future of analytics engineering. In this episode, I dig deep into the world of Apache Iceberg. If you're a data practitioner, you likely understand Iceberg as a user, why it's important, how it's changing the way that we construct data systems. But if you're anything like me, you may not know anything that's going on beneath the surface. But there is a lot going on under the surface. A lot of sausage getting made. There are multiple different ways to interface with Iceberg catalogs, multiple versions of the Iceberg REST spec. There's several leading catalogs that implement that spec. The whole thing is getting hashed out by an ecosystem that includes companies with market caps from tiny to ginormous in proprietary and open source code, in academic and commercial contexts. In a few years, all this ambiguity will be behind us, but right now, it's very much evolving in real time. In order to get an update on the status of the Iceberg ecosystem and walk us through all the developments, I asked Tristan Thiel to join me. Tristan's one of the lead architects of one of the most widely used Iceberg catalogs out there, Lakekeeper. And I learned a ton in our conversation. I think you will as well. Without further ado, let's get into it. Tristan, welcome to the Analytics Engineering Podcast. It's great to have you.
Thank you. Thanks for having me.
I have been excited to get you on for a little while. I think we're going to have a great conversation about Iceberg and the surrounding ecosystem. It's a little bit of a niche area in the grand scheme of like the economy. Spending a lot of time thinking about composable data platforms and open table formats and catalogs is a pretty niche area. How did you find your way to this?
I started off actually in like natural language processing, and then wanted to apply that in wanted to apply machine learning basically in the manufacturing industry after my studies. And as usual, when you want to, when you have a good application, what's often missing is the data. It's not there in time, it's not there in the quality that you needed. And so I got more and more into data architecture, data engineering. I've been a user for a long time. I've been in consulting, but then, we noticed that there is this gap that needed filling, right? Of a, Iceberg was there, but we're now in this gap of the Iceberg REST catalog. I think we're going to talk a little bit about that later. And and that's how I ended up, basically in the data area. I needed data, and it wasn't there in the way I needed it.
Wait, you were doing natural language processing and didn't have data that you needed? What was the domain? What was the problem set that you were trying to solve?
Well, so natural language processing and was what we did in university a lot. Back then, based on LSTMs, you wouldn't use them anymore today. And then, like, the problem set up afterwards in the industry that I had was actually actor-critic networks. So basically, implementing a control algorithm for machines, production machines, and you want to parameterize this machine as well as you can in an online manner. So while it's producing, and you want to parameterize it for each individual part that you produce, because every input part might be slightly different, and you want to optimize the machine to produce the perfect output.
I feel like the story of I was trying to solve a specific problem, and I just kept chasing the problem upstream until I realized I needed to build a data platform is like a thing that many people have done. Before we go deep into the Iceberg world itself, I just want to get our users familiar with Lakekeeper and what you do in your day job, because I think you have a perspective on a lot of these topics, and I want to just get that on the table.
Yeah, sure. So what I'm doing, I'm a co-founder of Bakamu, and we're like doing a few different kinds of things, but in our current stage, what we're building is mainly Lakekeeper, and Lakekeeper is an Iceberg REST catalog implementation. So it's basically a technical requirement and enabler to build these distributed composable analytic systems based on Apache Iceberg. But our vision is much grander than that. So what we actually want to do, I mean, it's nice if you have this, composable data ecosystem, but composable means that you have multiple parties, and those different parties, they need to work together. They need to collaborate. So we need to have more than just the common understanding of data, which Apache Iceberg provides. We also need we need contracts based on that. We need to somehow define and how we work together on data. And this is a lot of what we're building in the future around data contracts and around reliable sharing of data.
I am so on board with everything that you folks are working on. I left because Vekamo is currently, it's just two people, or is it three people? It's like small.
Yeah, we're currently 3 people. Yeah,
Three people.
we're raising, we're growing. Yeah.
And you're like, our aspirations are much grander than just building the global iceberg catalog of record. That by itself is like a pretty ambitious thing to do. I love I've read a little bit about the stuff you folks are working on with data contracts, and I think that's related to the event-based stuff that you got some stuff going on there in Iceberg 4 or something like that. But before we get deep into that, let's set some groundwork, do some context building. If you were talking to a, let's say, either a data engineer or a like VP of analytics at an enterprise, you could do either one of them, and they said, I've been hearing a lot about Iceberg. What's all this about? Why should I care about this? What's your answer?
Well, I think the simple answer is that for a long time we had these monolithic things that we call data warehouses built in a relational database system. And a relational database system is great. Like, it has everything included that it needed, right? You have the storage, you have the compute, but being this monolith is quite limiting to the use cases that you can solve with this in your company, right? So you might have different kinds of problems, and they require different kinds of query engines to solve them. And Apache Iceberg is this common understanding. It's a data format. It's the common understanding of data that different query engines um, can share to solve problems, right? So what we really want to have is we want to have centralized data. We want only one copy of our data. We don't want to copy it and ETL it from one system to the next and have multiple copies of it. Instead, we want one copy of our data. But we want to be able to switch and swap the compute engine so that we can choose the compute engine that we need. And Iceberg is the foundation of that. So there are multiple things that come together, right? So for one thing, we want to solve more use cases than we could have. It's also about, avoiding vendor lock-in. It's having data in an open format. Data is in the heart of our data platforms, right? It's the most central thing in our data and analytics system. So if there's one thing that should be open, it is the data at the heart of it. In addition, to the business logic that we have.
Let me just, for fun, for a second, take the devil's advocate, and just so you know, I'm a big Iceberg fan, and we're making a bunch of Iceberg investments at DBT Labs. So don't take this the wrong way. But let's for a second say that maybe I've been through the Hadoop period, and one of the things about Hadoop was lots of open standards and lots of best of breed technologies, and you attempted to do your best to kind of integrate them all together. And then what actually came out the other side was often like too complicated and too fragile to actually like run with any kind of economically viable number of humans. We moved as an ecosystem, we moved away from Hadoop and generally towards systems that were more commercial and more integrated. Snowflake or BigQuery or even Databricks, I would say, even though they're kind of lake-y, they like have a pretty single integrated platform, tries to make things easy. Is the vision of separating out data from the integrated platform really realistic? Like, have we ever seen this happen before? And should we be hopeful that it's really going to happen in the future?
Like, I think we see happening it now, right? So we used to have these closed platforms, basically, right? So big vendors like Snowflake and Databricks and the space, and of course they are still around. But because people actually want this openness there and want to switch and swap computes and don't want this very tight coupling to this one platform that this walled garden that everything works in, even the big vendors are now introducing Iceberg in their platform and actually embracing the format, right? We have seen the acquisition from Tabula last year by Databricks, and Snowflake has been investing also for time now in Iceberg, right? So even the big platforms are investing in it, and we see it popping up everywhere. And I think this is the great strength of Iceberg, that like all the vendors are embracing it. And um, so I think we already are at a stage where this is possible, right? This is not a question anymore. This is proven basically. And then maybe to address the other comment that you made, that this is a complex system, like I agree, right? Platforms, also in the future, will stay the easier approach, right? If you have a very small data team, then you can get up quickly using one of these platforms. Um, but then also open platforms are getting easier and easier to deploy and to run, right? So compare, for example, a modern setup with Iceberg with what you used to have in a Hadoop ecosystem. You used to have a very complex setup with Yarn, with everything else that belonged to that. And today, I mean, Lakekeeper is a 35 megabyte binary, for example, that you can deploy anywhere, run anywhere. It's super easy to get started. There's a Helm chart, Docker Compose. There's everything there that you need. And you can take an off-the-shelf object stores. There are plenty out there. And most on-premise deployments of storages, they already come with some form of, S3. Or you just book it from a hyperscaler, right? And so all the technology, the technology has evolved a lot over the years, right? And so it has become much easier to host these data platforms yourself.
In the Hadoop era, we barely had Kubernetes or Terraform or any of these kind of like enabling technologies that allow us to package up stuff more effectively. One of the things that I think happens when we talk about Iceberg and open table formats generally is that we start talking about an idea and stop talking about technology. So I think that everything that you've said so far in terms of the benefits of Iceberg, I think is like pretty uncontroversial and probably fairly widely understood. I do think that it gets harder to map when you go a level deeper. But my understanding is, you please either correct me or maybe extend this, but is that Iceberg's really a combination of a, a metadata format for adding metadata to Parquet files that define a table. Things like where are the different, where should I look for a given piece of data within a set of Parquet files? And it is also a catalog spec that sits on top of that so that you can know, if you're a compute platform, how do you integrate with data stored in Iceberg? You need some kind of serving layers, a stateful layer that tells you, like, here's where you go get the most recent copy of a file, or things like that. Is that a reasonable mental model? Like there's actually like physical metadata that gets stored on disk, and then there's like a catalog that kind of sits on top of that.
Yeah, I think that's quite accurate. Yeah. So I mean, Iceberg is a hierarchy that's composed of different levels. It's basically metadata hierarchy that sits on top of well, as you said, Parquet files on top of data, right? But actually, this is one area where I expect quite some movement in the future. So different folks are working on different file formats that are optimized for different use cases. And I think there are some really promising that might replace Parquet in some
Can you say
deployment.
more about that? I'm not familiar.
So there are many companies working on proprietary formats, Lance, for example, LanceDB. Yeah, but yeah, we will see where it goes, right?
This could be file formats that are optimized for particular, whether it's time series or other use cases that they perform better in those contexts.
Yeah, yeah, storing more statistics, other use cases. Yeah, exactly.
Okay.
And Iceberg's open to that, right? Historically, we already had we had RC as well and Parquet, and of course Parquet kind of became the default, but Iceberg's open to the file format. What Iceberg really is the metadata tree on top of that. So you have, well, at the very top level of the hierarchy, you have the table metadata JSON. Basically, it's a file that contains high level information about a table. So, for example, you find in there all the snapshots of the table. You have a little history. You have the schema of the table. You also have the location and things like that. So it's a very high level file. And then you have multiple layers below. For example, you have manifest lists. So each snapshot basically is a file somewhere on S3, stored in an Avro format. And then you have actual manifests. So you have a hierarchy level. And the highest most level of this hierarchy, this table metadata JSON that I was just talking about, this is something that needs a centralized state. There should only ever be one valid state of a table, right? So this needs to be centrally governed. And this is the bit, only this top level is what is well stored in Iceberg in a catalog, or at least sometimes it's also stored on disk, and then the catalog points to it. The important point is, so the first use case for a catalog was that different file systems out there didn't support a way to atomically forward this table metadata file with a new version. So let's say you updated the table, then you need to update this table metadata file, and doing this atomically isn't possible in all file systems. And this was when people's first starting to experiment with catalogs. Because if you have, this central place, the central catalog, which stores traditionally, for example, like Hive, a pointer to this file, then you could use, Hive's lock mechanic to lock the table metadata, do your update, and then save a new version, right? And this way you have done an atomic transaction. And this is how catalog started. So it's basically the catalog is the highest layer of this hierarchy of Iceberg metadata, and it's really the source of truth for metadata. And then people discovered that now that you have this catalog where you store this top level file of a table, you can do more than just be a technical necessity.
Wait, before we go there, I want to follow you down this path, but I just want to make sure that this point is not lost. When you have a database, you have kind of two things. You have data on disk, and then you have a mechanism to point to where to go to get the most recent copy of the data on disk. I think that as analytics professionals, we often don't spend a lot of time thinking about the technical details of like, how does one provide ACID compliance as a part of a database? I have for a long time known what ACID compliance was because I wanted to make sure that I knew how I could chain multiple operations together and I could roll back the entire thing if I needed to. All of this stuff like matters to people working in databases, but I never needed to know the answer to like, how did that all work? So this idea of a catalog that kind of maintains the state, and imagine you've got a Parquet file and you need to append to it, you might actually need to, and tell me if I've done so little work with like the raw files in my life, but I think that if you append to an existing Parquet file, you actually have to rewrite that file because in S3 you can't just like edit existing files, which is wild to me. And so it becomes a new file, and then the pointer gets updated to point to the new file. Is that correct?
This isn't really even a like S3 limitation. It's a Parquet limitation, right? It's so typically, and also maybe that's the first point. Second point is you actually don't want to update a file. You want to write a new file. Why is that? Well, Iceberg works. Iceberg has a feature called time travel, which is kind of the side effect of that. Basically, this means that when you like every change that you make to the table actually writes files. You never delete a file unless you have special cleanup operations. And this, of course, is only possible like if you always only write. So how an Iceberg transaction typically works is Iceberg adheres to the principle of optimistic concurrency, right? So you have a process, and this process wants to write something. Then it assumes that it is the only one writing, basically, or at least that its own changes are compatible with anyone else writing. And then it just starts to produce files, new Parquet files, new metadata files. And then when it's done, the process tells the catalog, I'm done. I made these changes. And I require a certain state of the table or a partial state of the table. The catalog checks those, and then it might reject the whole transaction because whatever the client did was not, you know, compatible with whatever happened in the meantime. So, and this optimistic principle manifests technically by every change being something written to the table. So let's assume now that we want to do something. I guess if we ingest a row, that's pretty clear, right? So you write those new rows into a new Parquet file, and then you add this new Parquet file to your table, and you have added some rows. Congratulations. Now, what's probably a little bit harder is what do you do if a row gets deleted, right? Now, maybe just one row out of this Parquet file that has hundreds of thousands of rows gets deleted? Well, you have a few options how you can do this. The first option is, well, you can, as you said, actually rewrite the file. So you take the old file, you remove this one row, and you write out the whole thing again under a new name. And then in your new table state, you remove the old Parquet file, you add the new Parquet file, and voila, you have deleted a row. This, of course, can be expensive, but it's the most read performant version that you can do because the reader doesn't have to do any kind of merging. The second option that you could do is you could write a so-called deletion vector, which is actually a very new feature in Iceberg v3. There have been other mechanisms in older Iceberg versions.
I feel like I've been hearing about deletion vectors a lot for the
Yeah,
last 6 months. I'm like, I don't know anything about. Is it just kind of like a soft delete, essentially?
it's basically kind of a soft delete. Yeah, so you store a so-called like a bitmap, basically a roaring bitmap, in a file where you just say these rows are deleted, and then whoever reads the table reads, the actual file and the information of what was deleted, merges everything by basically just binary mask, keep these rows, delete others, and return the result. Yeah, so this is how it works.
So I've really enjoyed this trip down the technical details. I want to come back after one more question. The last question is, you could imagine that if you're a data practitioner and you are thinking like, oh my God, I know exactly what's happening in my data platform. Like there are constantly rows getting written to all kinds of tables from different locations, from Fivetran and Airbyte and DBT and blah blah blah. Like all these different writers are constantly doing this, and with every one of these changes, like I feel like my tables are getting more fragmented and more disorganized. So like there's also some kind of like background process daemon that goes up and kind of cleans up everything and optimizes everything. Is that fair?
That's fair to say, yeah. So there are a couple of procedures basically that, would have to run manually on Iceberg tables unless you have, a service doing it for you, the daemon that you were talking about. And I think like the two most important of these processes is first of all expiring snapshots. Like as we discussed before, we're always adding new files to this table. So eventually, we can't pile them up forever. Is eventually we want to, cut maybe after.
Which is why your time travel will have a window of X
Yeah,
days on it.
exactly. So this is what expire snapshot does, right? Search the old non-referenced things and get rid of them. And then the second one is compaction. So if and that's especially important if you stream into a table. If you have lots of small updates into a table, then small files accumulate, and that's expensive on various levels. While planning a query, you need to respect all of these different files. You need more pruning and so on and so on. So what compaction does is it takes all of these smaller files out there and regroups them, in bigger Parquet files that are much more efficient to read with, 256 megabytes in size or something like that. You can specify the
I was
target.
just going to ask you, is there like a magic file size?
That's actually a very interesting topic there because, like, the file size actually depends a little bit the optimal file size on your query engine. So, for
Yeah.
example, if you have a Snowflake managed tables, Snowflake works with something like micro partitions. These files are tiny, and if you have like 16 megabytes or so, and if you have an external query engine like Spark doesn't like that too much, having these files so small. So for Spark, actually, a much larger file size would be optimal. So that kind of depends on your query engine, but I think like a good range is something between 128 megabytes and probably a gigabyte or so for very large tables.
Very interesting. Okay, so a few minutes ago, you were starting to tell us, like, okay, now that we know that we need a catalog to provide these pointers and manage state across multiple different readers and writers, there's other stuff that you can realize that you can do with it. I'd be interested to get the list of stuff that catalogs are now becoming responsible for. But I think that the first big one is governance, right? Like making
Yeah.
sure the right people read and the right data.
Exactly, yes. Access controls, governance is one of the core features. Maybe before we dive into that, like one very like other important feature is just multi-table transactions, right? Like that's something that there has actually been a demo. You can do this with some file system that support atomic like swaps and so on, but that's also something that you only get with a catalog, multi-table transactions, and all Iceberg REST catalogs are capable of that. Or well, most, I guess. We are, Lakekeeper is at least, yeah. And so, like, coming back to your question, so what's governance, right? And how can a catalog do this? So this is actually something that became much more important when the Iceberg REST catalog specification was introduced. So Iceberg has had multiple catalogs over the years, right? We have had the Hive catalog that we like talked about before, basically just a pointer to this metadata file somewhere, which had a lot of problems. So Hive relied on a lock. What do you do if you acquire the lock and then as a process you get OOM killed or something else? Not a good position to be in, right? And there were other catalogs as well, JDBC, for example. So storing this pointer basically in a relational database system. But they all had, some kind of problems of different kinds. I don't think we need to go into too much detail there. But so now with the REST catalog specification, which is what all what all modern Iceberg catalogs use, you have much more control over access to a table. So I guess one of the most fundamental things that you want to do as a catalog is you want to manage access to this table, right? And this includes giving a query engine access to the files because you don't want to hand them out as a catalog, right? You still want the query engine to go to your object store and read a Parquet file. So if you as a catalog control who has access to a table or are connected to this, system that knows, then how do you enable the query engine to do this?
This is great. I want to make sure that I have the. So you said something interesting. You said, I don't want to, as the catalog, hand out the access to the data.
The access I want to hand out, just not the file, right?
Well, okay, sorry, I said
Yeah.
it the wrong way. I am imagining, okay, I'm the system that wants some data. So I make a request. The first request needs to go to the catalog,
Yeah.
and the catalog is going to return to me a pointer. Where do I then go to get the data that I'm looking for? Is that correct?
Yeah. So there are two ways how to do this. There is the way where the ca- the catalog returns the table metadata to the client, and then the client, follows these snapshots around this hierarchy of metadata until it arrives at some, data files. And then there is a second way, which was introduced just last year into the Iceberg REST specification, which is where which is called server-side planning or scanning, where the client actually offloads this work. So it just says, well, I want to query this table with some predicates, so with some filters being set, basically. And then the catalog is responsible in figuring out like what Parquet files to read. And if the catalog can do this, then this has the benefit of, you can cache the plans, for example. You can make planning much more efficient.
Huh. That's interesting. It splits the job of the query planner a little bit
Yeah,
between yeah, okay.
exactly. Yeah. But you still end up with the same problem eventually. Eventually the client, needs to read files.
Sure.
So how does it do that without, having credentials on the storage? There are two different ways in how the Iceberg REST how an Iceberg REST server can enable a client to read files. The first one is using valid credentials, and I think this is the most widely used today. And this is, well, actually quite simple. So if a client goes to, Lakekeeper and says, well, I want to read this table, then Lakekeeper checks, is the client allowed to, right? Is the token valid? Do I have access? So all of this process. And then Lakekeeper goes to the um, storage system of, let's say, S3, and it generates a temporary token, right? Credentials that have a very, very short runtime lifetime, and that they are just valid for the files that the client needs to read. And then the client starts reading those files, and there is also a mechanism built in how the client can refresh this.
It's a little bit like my Apple Pay. It generates like a one-time use code that works for
Yeah,
my credit card.
exactly. Yeah, it comes built in with a session token. It's very cheap to create these credentials, much cheaper than having full blown access credentials to your storage. typically. And there are mechanisms for this, like short-term access in all of the storages of the hyperscalers. So with S3, also with on-premise S3 storages, right? So this is not just an AWS thing. You typically have an endpoint that is called STS, Secure Token Service. And this service hands out these tokens. For Azure, for example, you use SAS tokens. And yeah, so you have these mechanisms everywhere where you can, attach an inline policy to a token and then just hand back this token to the client.
Got it. So you said there are two. I had heard of vended credentials before. I'm not familiar with the other approach.
The other approach is remote signing, and it only works for S3.
Hmm.
And the principle there is a little bit different. So with remote signing, you don't hand credentials for a full like table locations back to the client. Instead, the client itself, when it wants to access a file on S3, it generates the request that it would send to S3. But instead of sending this request to S3, it actually sends it to the catalog. Not the full request, especially not if you write a file. You don't want to include the body. You just include the headers of the request. So basically, the location where you want to write, for example. And the catalog inspects these headers, checks if the location, if the client is allowed to actually write to this location or read this specific file. It signs the request, which with its own credentials, and returns everything to the client. And then the client can use these signed headers that it obtained from the server to do the operation that it needs to do. So this is the second way.
If we want to go deeper on the list of like things that Iceberg REST catalogs are now able to or expected to do, I'm interested to go there. But also, just I want to start digging into enterprise readiness.
Mhm.
If you asked me a year ago, how ready is Iceberg to go into production at a Fortune 100 enterprise that was using two of the main data platforms? Let's just, for the sake of argument, say that they were using Redshift and BigQuery side by side. And my thinking around this topic would have been much more about, well, what platforms support what operations, like write versus, where was the state of the performance on the different platforms. Sometimes the internal storage is significantly more performant, but like today, I think those things are getting worked out. I think that, for example, I think that Christian Kleinerman was on stage at Snowflake Summit saying that performance on Iceberg is either at parity or very close to at parity with internal Snowflake tables. And I think they've got their checklist of like compatibility of different operations is like very, very high. But where are we on the maturity of the governance and access control stuff? Because if you use an integrated platform, that stuff you don't kind of have to think about that much. It all kind of works. Are we there on the Iceberg side?
That being said, authentication, authorization, permissions in general are not part of the Iceberg specification, right? So this is something um, that different, implementations of a catalog server have to take care of. We don't have a standard for this.
That's so interesting. But everybody agrees that this is a thing that the catalog has to do, but it's not a part of the standard.
No, it's not a part of the standard. What is a part of the standard is like a single line, and even that is, kind of like more of a hint than, a requirement. And that is in the what well, actually, maybe we start differently. Like what is actually part of the Iceberg project is the standard of the REST interface and open API specification of how this, REST catalog should talk to. But this has just a single line at the very top saying that authentication is done via OAuth 2. And this is also more like a recommendation. So Iceberg is actually open to the authentication mechanism that you use. For example, if you use Iceberg on AWS, you use a different mechanism, SigB4, which is native to the AWS platform. So um, so yeah, so what I'm saying is this is not part of the specification. Of course, it is super important to have this kind of thing, right? Now, let's maybe discuss briefly of what clients need to agree on and what clients don't need to agree on. Because so there are like two phases when you want to access a table that you need to govern, right? First, there's authentication, and authentication is the process of identifying a client, identifying who is who, making sure that the person who claims to be maybe Tristan is actually Tristan by providing a token that only you can have. Um, and this authentication process happens, of course, between the client and the server, right? So a client claims, I'm Tristan's by Iceberg, and I want to access this table, and it needs to authenticate. So authentication is actually something that clients need to agree on. And luckily today we have very good authentication standards out there around, OAuth 2 specifically, that basically the whole community implements. So not all query engines implement it equally well, but it's there in a basic form in most of them, and it is the most widely adopted standard. And there has been a lot of movement in there recently as well. So basically, the community agrees that OAuth 2 is, a very important standard there, and that all clients basically should support this. Now, the second process that you need to access a table is you need to go through authorization. And authorization is the process of checking if somebody is allowed to access the table. So I know that you're Tristan, right? But I still need to check, is Tristan part of this specific team? And then maybe I give you access or I don't, right? So this is the process of authorization. And this is something that clients don't need to know that much about, right? Because if you have your permissions stored in somewhere close to the catalog or in the catalog, and the catalog enforces this, well, then the client doesn't need to know about this. So this doesn't need standardization as part of the Iceberg project.
That's breaking my brain a little bit. So there's standardization that you need to have a bunch of clients that can all integrate seamlessly to any kind of Iceberg standard REST catalog. Fine. But then there's a bunch of REST catalogs, Lakekeeper being one, and you would think that you'd want them to have fairly similar ideas on how to do something as straightforward as authorization. Not straightforward, but like something as basic that everyone needs. Are you saying that it is possible that every Polaris and Unity and Lakekeeper and all of these, they all do authorization differently?
Exactly, yeah, and that is absolutely true today. So let's take let's take or make a simple example. So with Lakekeeper, for example, we're actually open to different authorizers. So Lakekeeper's written in Rust, right? And you have a trade that's called authorizer, and you can implement it in any way you like. And we have some of our clients implementing their own authorizers to connect to their own permission systems in their enterprises. And we have, uh, but we have, of course, a standard implementation that is open source that everyone can use, which is based on a concept called relationship-based access control from the Google Zanzibar paper. It's a super powerful concept. It's a superset of RBUG and ABUG and everything else. It works a lot with inheritance and things like that. But we're the only ones that have this kind of permission model. If you look, for example, at Polaris, you have more of a policy-based permission model on there. That also has much less inheritance. So, for example, in Lakekeeper, permissions can bubble up and down. You can also prohibit them from bubbling up and down. But the model is quite different. Yes, yeah. I'm really I really like our model because we can in modern data teams, right? So we used to have this relational database, and everyone is comparing lake houses to relational database. And relational databases, they had three levels of hierarchies internally, right? You had a database, then you had a schema, and you had your table. With Iceberg or with file systems in general, you're not limited to three layers. And why should you still stick to this? And so many principles or governance or permission models, this is just permissions is just a very, very small part of governance, right? But um, these permission models that you had in, ANSI SQL or in these old database systems where you basically needed a use statement on each hierarchy level to grant someone access to a table is just not keeping up with requirements of modern data teams that are much more diverse and much more structured, that want a much more flexible way to grant permissions.
In the version of the world that you're talking about here, and I understand that this is like the most basic question ever, but is it possible Okay, here's a very common DBT pattern. You build a new table by making a model and transforming a bunch of data that's elsewhere. And then you, as a final step in the process of creating that table, you write a grant statement and you specify the roles that you want to have access to the table that you just created. In a world where Lakekeeper is governing this stuff, do I still write a grant statement?
That depends actually on the authorizer that Lakekeeper is using. In many times, actually not, because you might want your permissions you might want to store your permissions in a more declarative way. So, for example, Open Policy Agent is something that you see a lot around out there, right? So, a grant statement is an implicit way to grant a permission, right? So, you grant something, which means is you change the state of something. Instead, what some especially larger enterprises want is they want to have a Git repository with all the permissions in it, and then it's very similar, to Kubernetes, where you have a declarative way to deploy something. You just say, I want this state, and I don't care how you get there, but I want to get there. So you can have this in this external system. And also, yeah, also with Rebug, with what we're using, you typically you wouldn't use these grant statements. You would manage permissions elsewhere.
Got it. That's fascinating. It makes a lot of sense. I mean, the code to express the business logic of the transformation that you need is just not at all similar than the code to grant access to the table that you just created. So yeah, that makes a lot of sense. When you pull access, one of the nice things about a database system is that you can operate the entire database system from purely SQL, and everybody that knows SQL can kind of do all the things that they need to do. And when you kind of start pulling features out of that context, you need to use a bunch more tools, and then that makes the management of that different or more complex for different humans. But I will be fascinated to figure out how we implement permissions for DBT plus Lakekeeper. Will be fun.
Yeah.
Can you give me a sense of the different Iceberg REST catalogs that are out there today, and what are the dimensions along which people are making decisions about what catalog to use?
As of today, we have kind of four like bigger implementations out there. Um, so we have from each of the big vendors, there is one catalog. So there is the Databricks Unity catalog, and there is the Polaris catalog, which was originally open sourced by Snowflake. And then there is Lakekeeper, there's us, and then there is from Data Strato, there is Gravitinium, and these are the main catalogs currently out there, and they are quite different in various different ways. So something that
Did you mention Glue in the list?
well, actually, yeah, no, I did not, but you're right. Actually, Glue now also supports the Iceberg REST interface. They haven't for a long time, right? It used to be the Glue REST interface, which was something specific to Glue.
Got it.
But now Glue also supports.
So they joined the party recently.
Yes.
Okay.
Yeah. With it came with the introduction of S3 tables. Yeah.
Got it. Okay. Sorry, I interrupted your train of thought.
No, all good. Yeah, and these are like the catalogs currently out there. So basically, I think what users should like care about is, or let's put it the other way, like things that we really care about, and that I think differentiate us is the ease of use, right? So, um, like we come with a UI. If you look at Polaris, like there is no UI. It's a very developer like centric tool, right? And we want to be easy to use. Data shouldn't be this, developer centric. It should appeal to data engineers, and not to programmers or someone being able to build the jar himself using Gradle, which is something that you would still need to do there. So we want to make it really easy to use. We also like want to be a very minimal in the sense that like small binary size and very very fast implementation. So we are completely written in Rust, and we're the only ones currently out there that do this. So we are like by far the fastest catalog out there.
And this is a space that performance matters.
Performance matters, yeah, absolutely, especially if you have streaming ingestions and things like that. And one of the main reasons why we do this is that we really like a catalog also needs a database in the background, right? Data needs to live somewhere. And Lakekeeper uses Postgres for that. So Lakekeeper stores its own metadata in Postgres. And we have a normalized database model, right? Old fashioned application design, a very normalized data model. But this allows us to do things like, search for tables that have a certain property or things like that. So this gives us a lot of freedom, but also makes transactions super fast. Um, and this is like very different from implementations, for example, like Polaris that are able to work with key value stores or different kinds of SQL databases, but basically treat them all as a key value store. So this is something that makes us a little bit faster. Extendability is the next point. So like from the beginning, we wanted to make something that folks can integrate with in their own system. So what does that mean? So I mean, very basically, on a very basic level, you want to integrate with your IDP, right? With your identity provider. Try and use Polaris for that. There is an interface, but you have to implement the token provider yourself, right? So with us, this ships out of the box. Also in the open source version, like it's there and it should be there. It's security. It's a basic requirement. Um, yeah, and like we are open in other ways as well. So switching out the authorization provider, switching out an event interface that people can use to event alert on changes that happened, and all of these different changes led to Lakekeeper being like integrated in various different systems out there. So like we have very very large users out there who use Lakekeeper on a global scale, and they do so mainly because they can extend it and integrate it into their own cloud offerings, right? Yeah. So you wouldn't even like there are some catalogs out there you wouldn't even know that Lakekeeper is behind the scenes.
I wonder if you could share a little bit about there was an announcement that came out of DuckDB.
Ah, yeah, Duck Lake.
As of the time we're speaking, it was maybe 4 weeks ago, 6 weeks ago, something like that. And yeah, Duck Lake. And I have not spent enough time there to feel like I truly understand what I should think about this. It's obviously very like in the Iceberg ecosystem, but I
Yeah.
don't think it is an Iceberg compatible REST interface. So what are the pros and the cons? What is your overall thoughts?
Maybe let's start with the cons, because I think they made two mistakes that I want to end on a positive note, right? I have a
Okay,
few
got it.
positive things to say as well. I just want to get these two out first. So I think like when I first looked at the specification, I thought, well, they made two mistakes that others had made in the past, and I really don't understand why they repeated it. The first mistake is why so Duck Lake uses as a catalog. It also needs a catalog, every table format needs a catalog. It uses a relational database schema. And in that way, it is very similar to what Iceberg had with the JDBC catalog back in the day. But Iceberg decided to bury it. Now, why is that? Well, the catalog is a little bit of logic, right? It's not super trivial. You need to implement a little bit there. And um, basically having a database as an interface has been a very bad idea for a very long time. This is why we introduced, APIs eventually. And so basically, what an interoperable Duck Lake would require is having different query engines, maybe even written in multiple query languages, all modifying tables in the same database. And this is not really going to work. And this is also why Iceberg moved away from the JDBC catalog. Basically, you needed to ship this JDBC jar into all different systems that wanted to connect to your catalog, and this just wasn't going to happen. The second problem that I think is there, but I think like they are making a good job in trying to remedy that a little bit now, is they built the whole thing without a community, right? It came out of the black box. It just was announced and here it is. And well, we also had that in the past, right? We had Delta Lake, and now eventually Databricks also is moving to Iceberg and paid a dear price for that, basically. So an open format, an open data lake format needs to be built by a very strong community that agrees on this. And of course, this sometimes means
Because there's a million integrations. There's like
exactly,
lots and lots of edge
yeah.
space for people to innovate in.
And that means that sometimes, things go a little bit slower. Sure, if you have, one big company deciding, well, I want this feature, I'm building it now. And there is nobody saying no, right? So it's fast, but if it's not built with the community, it lacks adoption, right? And we will see how Duck Lake um, handles this in the future. But for an open format, like if they want to be an open format, um, having a community and being integrated in everything is, of course, super important. So I guess these are like the two drawbacks that I see from a very architectural perspective. That being said, for heavy users of DuckDB, I mean, DuckDB is currently the only query engine that supports this. And for heavy users of DuckDB, of course, this could be a very good way forward, right? Because we said before that also when in integrated systems you could do more optimizations that you could probably in distributed systems and open formats. So DuckDB has the chance here to build in exactly the statistics that they need to run super performant queries, so they can be faster than Iceberg, right? Not sure if they are. I haven't seen any benchmarks, but the possibility is certainly there. And then, of course, there is the possibility of the broader ecosystem adopting it, and this is going to be key if it wants to succeed as an open table format. In contrast to just the format that you would use for DuckDB, and it happens to have an open specification flying around on the Apache license somewhere, right? So um, yeah, just having the right license doesn't mean that you're an open format. Openness comes from adoption across the ecosystem, and we'll see if DuckDB gets there.
Let's close out real quick on where is Lakekeeper on your journey today? My understanding is that most of the work you're doing right now is open source. Are you also hard at work on a commercial platform and anything like that?
Yeah, so we are. So first of all, already today we offer Lakekeeper Plus, which is like an enterprise distribution of it. We're also thinking about like open sourcing the code, but under a more restrictive license. Basically, what it comes with mainly is things around table optimization. That, as we said before, the daemon that runs in the background that keeps your tables tidy. So this is, one area that we currently work in. We're also building a managed platform, but this will take a little bit of a longer time. Also, because many people choose us because they want to run us, in their own, as part of their own offerings or in their own clouds somewhere, and yeah, well, not use a managed offering out there. There are other managed offerings already out there. Yeah, and then we're extending a lot in, well, the area, of contracts and data collaboration. So what we always say is, with Lakekeeper, we enable an open data ecosystem. But in the future, with what we build with what we call Covenant, our data contract library, is a lot around data collaboration that goes far beyond and reliability in data. In collaborating on data that goes far beyond just sharing data. And because we have, Lakekeeper as a catalog out there, um, we can, for example, we can tap deep into transactions and, for example, stop changes from happening that we don't want to happen, right?
Hmm.
So let's say you have a downstream process that requires, a field to be there, and now you go ahead and rename that because you thought it would be a good idea to have a clearer name. Well, then everything downstream breaks. The Lakekeeper can actually stop this from happening. So the broader vision for the future is really having reliable data processes that that work together. Basically, what I always call building the unbreakable lakehouse, including business information and a lot around reliability. Actually, pretty similar to where I guess from a broader vision perspective, DBT Fusion also can go, right? Just on a different level. Like we're addressing this problem of robust collaboration from a catalog perspective and say, well, we don't want certain things to happen. And then with DBT Fusion, you have, different projects. And if you manage to integrate them all together, you can have similar kind of guarantees if people use exactly this kind of tooling. So yeah, also something that if we had a good standard there, just saying, for data contracts or something, we could also address or enforce the same set of shared principles or agreements across different engines.
Love that. Well, Christian, thank you so much for joining me today. This was a fantastic conversation. I learned a lot, and wish you and the team over there nothing but the best.
Thank you very much. Thank you for having us, and for you too. All the best.
The Analytics Engineering Podcast is sponsored by DBT Labs. I'm your host, Tristan Handy. Email us at podcast@dbtlabs.com with comments and guest suggestions. Our producers are Jeff Fox and Dan Poppy. If you enjoyed the show, drop us a review or share with a friend. Thanks for listening.